Okay, good afternoon, everyone. Sorry for the delay. Due to some technical issues, we are unable to start on time because of the giving access and the previous link was not working. Um, uh, and you are all patiently waiting for the lecture. And this is our International Lecture Series 1 under topic 3. And we are having a very good resource person from our Nishi group, that is Dr. B.Bindhu, Professor and Head, Department of Physics, Dean, Faculty of Science and Humanities, and Director for Student Affairs. She will be giving a talk on the 2D marvels, unlocking the power of materials for sustainable future. Without much ado, I will hand over the session to Dr. Bindhu for further. Bindhu, madam.
Yeah, thank you, sir. Hello, everyone. Very good afternoon to one and all. Today, let me take this opportunity to express my special thanks to Dr. Lalu Gladson, who's the International Affairs Director of Noorul from Center for Higher Education, and his team for inviting me as a speaker for this lecture series in association with Gambella University. I also express my sincere thanks to the authorities of Gambella University for giving me a chance to reveal the secret of materials. And my contact info is provided in the screen. I hope the screen is visible to all the audience. And it is my first name followed by the letter B at naunib.com. So this is the information to connect with me.
Madam, can you put it in the presentation mode?
It is in the presentation. It is in the presentation mode, sir.
No. Presentation.
Okay.
Just full screen. There's the slides in full screen.
Yeah, please. Is it visible, sir? Is it visible, sir? Am I audible, sir?
Yes, madam. Yes.
Okay.
You can continue.
Okay. Thank you once again. I thank one and all, each one of you was present here. So let me move on to my topic of presentation. The topic which I would like to discuss today is about the bundle materials and associated two-dimensional materials. So the topic of my presentation is 2D marvels, unlocking the power of materials for a sustainable future. So before getting into the material world, let me introduce the concept of sustainability, why we need sustainability, then the materials science, and how this 2D material is unveiling the potential for sustainability. So what is sustainability? So this definition of sustainability is given by UN Brundtland Commission in the year 1987, and it aims to meet the needs of the present without compromising the ability of the future generation to meet their own needs. That is to maintain the resources and to have optimal and effective utilization of the resources available. Our Earth planet has a limited amount of resources which are being exploited by human endeavors, and so a need to have this sustainable environment is very crucial need of the hour. And accordingly, 17 there are 17 sustainable goals which the UN has put forward, and it focuses on the left side, the right side of the image shows the different sustainable development goals aimed at. And it's a call for action. That is, all the countries have to put in their effort, and in order to have a sustainable living, not just for the human beings, for the animals and aquatic organisms too, so as to have a peaceful and sustainable future. So here in this, out of all the different sustainable goals discussed, I would like to discuss about the climate change, which is a very serious threat to our planet, and the effect of which is affecting the globe seriously. And climate change occurs due to the industrial revolution, which is the cause for the emission of hazardous pollutants, as well as the increase of carbon dioxide emission into the atmosphere, thereby increasing the CO2 level, leading to global warming and associated global rise of temperature, the disruption of the ecosystem, and the rise of the sea levels as well. So overexploitation will lead to mass extinction from the planet. So therefore, addressing to the local needs, the human needs, and the aquatic and all organisms on Earth, we need to consider all these factors which are causing threat to the globe, and we have to develop materials according to that, and for a sustainable living. So here, this work about sustainability was first given by Sash and his team, and they have given 6 transformation strategies to achieve the sustainable development goals through proper education, gender, and reducing the inequality, the ways and means to reduce the inequality, the health, well-being, and demography, energy decarbonization and sustainable industry, sustainable food, land, water, and oceans, sustainable cities and communities, and a digital revolution. So using these techniques, we are it is possible to achieve the sustainable development goals. And a study has been made by his team, and they have given the 6 strategies to achieve the SDGs. So I am moving from, so all of you would have got an idea about what sustainability is about, and how it impacts our, without proper care, how it impacts our globe and the humanity in general. So a solution for this is given. Being a physicist, I would like to look at the physics point of view in giving a solution to the problem. So material science is the area which deals with the study of structure, properties, and applications of materials. And it encompasses aspects of physics, chemistry, engineering, and nanotechnology. The world we live in is surrounded by large number of materials. And we are working with materials, and all the materials are being used for the production of energy, production of various technologies, and so on and so forth. So then, but this has led to the industrial 4.0, 5.0, and we are working towards industrial 5.0. So wherein new technologies are taking place, and but their consequences is it is having certain impact onto the environment, onto the planet where we live in. The resources are being depleted fossil fuels and coal and other things are used for energy productions and all that, and which is giving an adverse impact onto the climate change and to the human health. So we have to think about developing of new materials, and here in an area of nanotechnology has been brought in. The material science and further advancement has led to nanotechnology, and it is the art of manipulating matter at the very nanoscale. So all of us know what nanometer is all about. It is about 10⁻⁹ meter. And the figure shows a DNA sample having a dimension of about 2 nanometer. And the human hair zoomed through a lens on the right side. A single strand of human hair, it is having a dimension of 10⁵ nanometers. So such a very thick material, our single strand of human hair is when compared to the nano dimension, which is 10⁻⁹ meter. So it's a very small object, very small material that we are going to deal with. And why this nanotechnology has gained significant importance is because of its material properties. So it has got very unique and interesting properties, particularly high surface to volume ratio and more fraction of atoms are residing on the surface. So when and quantum confinement effect, and as a result of all these things, the bulk atom, which is inside the bulk material, so it will have interaction with many of the neighboring atoms surrounding it, and as a result, this interaction will influence the property of the materials. But when we bring down the material to nanoscale, that is to smaller dimensions, more number of atoms reside on the surface and less interaction with the neighboring atoms, the bulk atoms. And as a result, the property of the material is also getting changed. That is why when compared to the bulk material, the nanoscale material is having exemplary properties in general, particularly the electrical, thermal, mechanical, and optical properties. It is not just the size of the particle that matters, but the arrangement of atoms too matters. So here is an example. The figure shows the allotropes of carbon. So all the three, that is the buckyball, the diamond, and the graphite, all three are made up of carbon atoms. But the properties each of these materials shows is completely different the rest of the materials, rest of the carbon-based materials. So look at the buckyball. So it is a
Madam, sorry to interrupt. The slides are not moving.
Slides are not moving, sir.
Moving. It stays in the first slide itself.
Slides are not moving.
Madam, close the PPT and again you are opening the PPT.
Okay. Slides. Is it moving, sir?
Scrolling down.
Put it in the presentation mode, madam.
Yeah, it is in the presentation mode, sir.
Or you can put a.
Now it is okay.
Now
It's not okay.
But full screen, we wanted to put full screen. Slideshow.
That's it.
Is it moving, sir? Sir, are you able to see my slides moving?
Yes, madam.
Okay. So we talked about what sustainability is.
Madam, click F5.
Yes, it is in F5, sir. It is in full screen mode.
Okay, okay.
So clear, sir.
Yes, yes, no clear.
Madam, good afternoon, madam.
Yes, sir. Good afternoon, sir.
Yeah, I'm Tamil Arsu speaking from Gambela University.
Sir.
Madam, don't put F5.
It's not
If you
FI,
put
sir.
F5, yeah, if you put F5, it will be okay for you.
Okay.
Here, the slide won't move. Now it is moving.
Now it is moving. All right, sir. All right. All right.
Please, can you do once again?
Yes, sir. Yes, sir. Of course.
Try to move once again, madam.
Is it okay, sir?
Now it is moving. Now it is moving. You can go to your chapter.
Okay. So
Thank you.
what I
Thank
was
you, madam.
talking was with regard to sustainability and why do we need sustainability? So sustainability is nothing but meeting the present need without compromising on the future needs. So there are 17 sustainable development goals which I have spoken about and which are displayed in my screen onto the right. And out of these 17 sustainable development goal, I have taken climate change as a very significant threat, to the planet. And this is a very serious threat in this particular era. Where we live in. And this is due to the industrial revolution and which has led to enormous release of carbon dioxide into the atmosphere, thereby resulting in a very increase in global temperature and ultimately leading to the increase of sea level, glaciers melting, and ultimately it is disrupting the ecosystem. And if this trend continues to grow, then it will lead to overexploitation and mass extinction. A study has been made by Sachs and his team, and they have given various strategies. They have given 6 important transformation strategies to achieve all these sustainable development goals. These are the topic which we have covered previously. I believe that the screens or the slide is moving now. And is it moving, sir? Is it moving?
Yes, madam.
Yeah. Okay. So here I'm focusing on material science, which is my area of research, and materials plays a very crucial role to the survival of human, and to have a comfortable and sophisticated life, we rely on various kinds of material. And material science involves the study of properties, structure, design, and applications of materials. And therein, the materials which were used, the technological developments lead to various industrial products, and which in turn is affecting the globe very seriously. So people started to work on materials having potential properties so as to meet up these challenges. And therein, the area of nanotechnology, which is a branch of material science, started building, and nanomaterials was a branch of material science, and from which nanotechnology, which is the art and science of manipulating matter at the nanoscale, started, and miniature devices and all that has been constructed accordingly. What nanometer is all about, we all know that it is of the order of 10⁻⁹ meter, and the figure shows a DNA sample which is of 2 nanometer in dimension, whereas a single strand of human hair, it is of the order of 10⁵ nanometers. So we can imagine how small the nanomaterial is about. And why this nano material has gained its importance is because of its extremely unique properties, as high surface area to volume ratio, then quantum confinement effect, and because more amount of atoms reside on the surface when compared to the bulk material. So in the bulk material, atom at the bulk part, there is always continuous interaction with all the neighboring atoms in the bulk. So as a result, the properties of the bulk matter is quite different. And when we compare it with the nano material, at the nanoscale, most of the atoms reside on the surface. So their interaction with the bulk atoms are considered insignificant, and most of the surface atoms becomes more active, which results in different property and unique property for the material. And it is not just the size alone matters, but the arrangement of atoms too is a great concern. So here this diagram shows three different forms of carbon. So all are made out of carbon, but due to their arrangement, due to the way in which the atoms are arranged, the properties are entirely different. So buckyball is a carbon-16, a football type nanomaterial, and it shows a different. It is a can be prepared in the form of solution and can be used as there's inks and all that. So whereas diamond, which is very strong, we know the hardest material, that is also made out of carbon, but the arrangement is quite different from that of bulky ball and graphite. Graphite, that we all use in pencil lids, which is very feeble structure of carbon, and not carbon, arrangement of carbon, which can be easily broken up. So all the three are made out of carbon, but the properties they show is completely different in different aspects. So now, nano engineering, nature is the first nano engineer, we could say. So if you look at the lotus leaf, surface of the lotus leaf is always clean, and no impurities, no dust particles, nothing sticks to the surface. So why? Because the structure or the surface of the lotus leaves a spike-like arrangement, which helps in the repulsion of all the particles which stick onto the surface. And a similar kind with this, nature has already been more motherly to us in protecting us, giving us solutions for a clean surface. So with this technology, materials has been developed, and we prepare our own, we manufacture clothes which are stain resistant using the same kind of materials having spike-like structures, which helps in stain resistant, as well as the jet adhesion. The lizard, gets stick to the walls and all that. It can climb the vertical surfaces of the walls, and because due to the surface, due to its its palm is having a particular surface shown in the figure. So if this technology can also be, the materials can be developed using some similar kind of such structure, then that can facilitate in the future glue, where humans can also think of going, climbing in a vertical direction, as shown, just like the Spider-Man we are looking at. And when we talk about nanomaterials, I would like to highlight upon the dimensionality of the materials. That's materials are classified, nanomaterials are classified as zero-dimensional, one-dimensional, two-dimensional, and three-dimensional material. So what this zero-dimension, one-dimension, two-dimension, and three-dimension refers to is based upon the dimension size. We all know that material has got particularly three dimensions, namely X, Y, and Z, or Z. And if all the three dimensions of the material or in the nanoscale, then we call it as zero-dimensional material. So example includes quantum dots, graphene quantum dots, fullerenes, and so on. And whereas one-dimensional material, see, out of the three dimension, if one dimension is beyond the nanometer range, then we call such materials as one-dimensional materials. Examples of which includes nanowires, nanotubes, etc. And talking about two-dimensional material, which we are going to focus a little more in our topic of study. So here in this 2D materials, all the three dimensions, two dimensions are outside the nano range, and only one dimension, maybe the thickness, is in nanometer range, and such materials are called 2D materials. The examples include the wonder material graphene, hexagonal boron nitride, molybdenum disulfide transition metal oxides, and so on. And then what is three-dimensional material is, if all the three dimensions of the material, that is X, Y, Z, are outside the nano range, then we call that material as bulk 3D material. So bulk nanomaterials are examples of that. So this figure is showing the examples of 0D, 1D, 2D, and 3D materials. If you look at the quantum dots, nanowires, nanosheets, and bulk graphitic materials, and so on. And carbon exists in carbon showing all the three dimensions. That is, fullerene as a zero-dimensional nanomaterial, which is all the three dimensions in nanometer range. Then we have carbon nanotubes, where only one, the two dimensions, or one dimension is beyond nanoscale. That is, the length is beyond the nano dimension, nanoscale, maybe like 50 centimeter, we could say. The thickness and the diameter are in the nanometer range. And when we look at the graphene, two dimensions are outside the range, and only the thickness is in the nano range. So this gives you an example of 0D, 1D, and 2D nano materials. And now I would like to unlock the potential of 2D materials in various applications. I would like to inform about the various kinds of 2D materials that are available and that are being explored, and how it is being utilized in different segments of environment, energy, water, and so on. So out of the 2D materials, there are different kinds of 2D materials called graphene, reduced graphenes, MXCs, and TMDs, and covalent organic frameworks, etc. These are various 2D materials. And what is this 2D material? Is atomically thin sheet of material, very thin, one atom size of material. So that is called an atomically thin sheet of nanomaterial. So these figures are from the reports of B.Bindhu. They have discussed in their two-dimensional material a critical review of recent progress and properties and applications and future directions. So I've taken this image which shows the applications of these 2D materials in general. And Young et al. In their work has given ideas on how to produce this 2D material, how to synthesize the 2D materials. There are basically two methods of synthesizing, two broad methods of synthesizing the nanomaterials, particularly the 2D material. The bottom-up, top-down approach, and the bottom-up approach. In the top-down approach, we can employ the ultrasonication technique, high shear mixing, then grinding enabled exfoliation, ball milling, electrochemical based exfoliation. Whereas for bottom-up synthesis, we can use the direct CVD technique and wet chemistry methods, which includes solvothermal, hydrothermal methods, etc. And we can also dope these materials using certain other atoms, and we can modify its properties. Similarly, we can add it into composites, kind of polymers and various other mixtures to get composites made out of these 2D materials, and we can also assemble it one over the other to get superior properties. So these are the various routes by which 2D materials and associates composites can be prepared. These are some of the very significant properties of 2D materials, and based on that property, how they are applied, the relative application of the 2D material is also shown here. So 2D material has a very significant property that it possesses effective surface area. So as a result, it can be act as catalysts. It can be used as sensors for detecting some pollutants present in the air and all that. So then it exhibits high thermal and chemical stability. Because of this, they can be used for manufacturing batteries which run in extremely chemical environments. Then solar cells, we can utilize it for making supercapacitors, etc. And then they also possess excellent mechanical strength and optical properties. As a result of extreme mechanical strength, they can be used as a reinforcement element in concretes for making lightweight materials, etc. Using polymers, it can be employed into. And then it is also possessing best electrical conductivity. It has got high sensitivity to various gases, chemicals, etc. As a result, they can be used as photocatalytic devices and also sensors, and they're also used to prepare transistors. This is the general properties which I have highlighted about the 2D materials. Whatever 2D materials that are being explored and developed will have extremely good properties, as like the ones described, where it can be suitably applied in different areas to get better performance. So here I consider a few of the two materials for my discussions. One is graphene. The unveiling of 2D materials started with the invention of with the discovery of graphene. So graphene, it is also called as wonder material. It is one atom thick. It is millions of times thinner than a paper. And physics professors Keen and Novoslav, in the year 2010, they received the Nobel Prize for this discovery of this wonder material. They actually discovered this material in the year 2004, and it is very strong, extremely stronger than diamond, and its conductivity is mind-blowing. It is extremely good conducting property, better than copper. So with this advancement of 2D materials, till 2004, it was believed that two-dimensional materials is not possible theoretically because of its thermal instability at room temperatures. So, but with the discovery of graphene is, as you all know, that it is got out of graphite. You know that I have already shown the structure. So it is layered hexagonal structure, layered arrangement of atoms, carbon atoms are arranged layers, and a single layer of that graphite is which what we call as graphene. And this single layer is highly transparent. It is having very good conducting property, very extremely good electrical thermal conductivity, and then it is extremely strong. It can be used as flexible material, and it is optically transparent too. So these are some of the properties and applications of graphene, which I have already told you. It is a material which is having extremely good mechanical, electrical, thermal, and also it is impermeable to helium gas. It can be used to detect helium gas leakage. We know that helium is it is a limited resource available, and so hence its leakage can be tested using graphene because it is impermeable to the helium gas. And then graphene has potential application in various areas, including energy, conducting materials, protective coatings, and then even it is used for making space launch vehicles. We all know that the space launch vehicles are made out of aluminum, which is the lightest we thought of material. But now the graphene having extremely good strength, able to withstand high temperatures and all that, and more lighter, much lighter than all the available materials. Hence, these integration of these graphene into different materials are being explored presently in the research work. And a similar kind of 2D material is what I am going to talk about as hexagonal boron nitride. It also exhibits extreme good property, good thermal conductivity. It's an insulating material. It's an insulator. So it has got extremely good thermal insulating property, and it's also used in the preparation of membranes for water filtration and so on. And it is also chemically inert. And even hence materials made out of boron nitride can be used for extremely harsh environmental conditions, even during explosions and all that, in areas of explosion where possible explosions could happen. So this covering or sealing the containers with boron nitride based material could help us resolve several issues. And then, as I've discussed, hexagonal boron nitride, which is made of boron and nitrogen atoms, and it is having different properties, which I have already highlighted. It's an insulator. It is a very good thermal. It has got very good thermal conductivity. So hence it can be used as a thermal insulating material, thermal management material, and it can be also reinforced in composites because it possesses very good properties of strength and modulus of elasticity is concerned. And then it can also be used as a protective coating because it can withstand high temperatures. Therefore, in the explosive environments, it can be used. And then it is also used for biomedical applications because it is biocompatible to humans, and it exhibits ferroelectric properties. Therefore, it can be used as memory, sensor devices, and then it is also used in electronics as gate materials and all that. So these are some of the vital applications of hexagonal boron nitride. So I also highlight upon another 2D material, which is molybdenum disulfide, which is the material where we work on. Our team is working on with molybdenum disulfide, boron nitride, and graphene-based materials. So that's why I've taken these three 2D materials for the discussion. And this comprises of molybdenum atoms sandwiched between two layers of sulfur atoms, forming a hexagonal structure. And the right side shows the term image of MOS2, molybdenum disulfide nanosheet, which our team has prepared. And from the term image, it is very clear that, as I've already told, that a single sheet of this material is highly transparent. That shows the transparency of the material prepared. And it is a very good lubricant, and it is also used for sensing applications as membranes, and can also be used as semiconductors, a substitution or could be a replacement of silicon in the near future. So there are, out of all these wonders that the 2D materials produce, there are several challenges also faced by the 2D materials, especially the scalability of 2D materials, the heterostructure design of 2D materials, then waste handling, which is yet another serious matter to be discussed. And then obtaining a low temperature CVD process for getting 2D material is again a challenge. So how to address all these various challenges? So some of the strategies to overcome the challenges are what has been discussed. The scalability solution to produce large scale 2D material is a great challenge these days, and people are exploring various technologies to scale up to produce a high quantity or bulk quantity of these nanomaterials. So they are suggesting materials like roll to roll chemical vapor deposition technique, where 2D sheets are produced just like the same way newspaper is getting printed. So people are thinking on that angle to produce the 2D materials, and the process efficiency can be improved by optimizing the CVD process as well as using alternative routes for producing these 2D materials. And cost reduction strategies can be resolved by exploring more cheaper starting materials for preparing 2D materials. And then we can also find out a greener solution by using a non-hazardous solvent for preparing these nanomaterials. And then CVD CVD technique requires a lot of power. So if we utilize a renewable energy generated powers from, particularly from windmill and from energy sources like solar, sun, and all that, we could reduce the we could maintain the resources, whatever is available. And then integrating these 2D materials onto the substrate or onto electronic device itself is a challenge, and people are thinking of stamp-like technique or some polymer-based transfer technique to transfer the 2D material which is grown on a substrate onto the clean surface where electronic gates and transistors and other circuits are built in. And then heterostructure of these 2D materials is really very challenging area because heterostructure is combining of two different 2D materials one above the other to get a different kind of properties with different functionalities. So that also is an area where research is happening, and we have to work on to overcome the challenges already addressed. And these materials are used in sustainable, these 2D materials are explored in the sustainable development areas, particularly for energy areas, water purification areas, then for the construction materials and biocompatibility of materials, and it makes it fit for medical applications, and spintronics, which is a recent field of effective energy efficient computing, where also the 2D materials are being explored. So this is showing the utilization of 2D materials in the energy sector, particularly for storing of energy, harvesting of energy, conversion of energy, and transmission. Even for transmission and distribution also we can make use of this 2D materials like graphene, molybdenum disulfide, boronite anode. These three are the materials which are being explored. There are several more materials, MHC based materials, and some metal oxides are also explored to meet up the energy demands. And this is showing the water solution with the 2D materials. So here 2D materials are used to remove pollutants from water. It's used to remove salt content from water. So it's used for desalination, and hence it's used for the preparation of membranes, and which can enable recyclability or a reuse of wastewater. So in that process also we can think of using this 2D material, and work is going on so that water scarcity, we can limitations of water resource limitations and all that can be addressed using this 2D technology. And it can also be used in the construction areas. As I've told you that the large quantity of cement production will lead to carbon dioxide emission into the atmosphere and all that. So as a result, how to maintain the particular carbon dioxide level without further anymore rise, we can think about using these 2D materials into the concrete and thereby minimizing the amount of carbon usage to our materials and making it more eco-friendly as well. So this is 2D materials in construction. Similarly, these 2D material has a potentiality for use in biomedicine. Particularly, these are biocompatible materials. They can be, they can get along with the human system so well. So it is used as a truck carriers. It is used to used as implants also. It supports good exceptional properties. As a result, it can be used as implants, then to make artificial joints and etc. And then it's also used for bioimaging. And there are several other medical applications of 2D material because they are sensors. They are good sensors as well. So hence they are used for imaging of structures as well. Then spintronics is another area of electronics and where energy efficient computing is possible, miniaturization of devices is possible with all the 2D materials which I have discussed herein. And it enables faster computation. The quantum computing technologies are all enabled with the advancement of these 2D materials. So 2D materials for a circular economy and reuse of waste. Circular economy is about reuse of the waste materials. So how to reduce the pollution and reduce the waste, how to conserve our planet, that should be the thought process for sustainability. So accordingly, now researchers are coming with techniques of developing graphene even from the waste material. For example, the waste carbon methane that goes out to the atmosphere. So from which people started working on to get graphene out of that material and use it. So this enables circular economy too. And how these 2D materials, as I've told, that it is processing enhanced durability, then it has got improved recyclability options, and hence it promotes, hence it is utilized in several areas without having concern on the sustainability. So this shows some of the applications wherein we can use the 2D material, particularly in electronics, in industries, in composite, all the applications which I have already discussed with is compiled together. And as I told, it can be used in photovoltaics for communication, LED switching, sensoring, and modulation. So these are the futuristic materials. So we call these 2D materials as a futuristic material because it aims to fulfill or aims to achieve the UN Sustainable Development Goals. So all countries, if we work towards having a sustainable ecosystem, then with materials, then this is the area where I put forwarding, and it's an eye opener to all the researchers in the area. And we also look for a collaborative research work related to similar kind of 2D materials. And anyone who's interested can we are welcoming warm hands. Join us for this venture on 2D materials and contributing to the sustainability of the environment. So with this, I would like to give a conclusion about my talk that 2D is a potential material, which is the futuristic material for a sustainable growth and a sustainable environment. Thank you all for the patient listening. Now I welcome questions, if any. Hello? Any questions from the audience?
Okay. If you have a question, please raise your hand and anybody can ask. Nice.
Yes, please.
Let me ask you, madam.
Yes, sir. Yes, sir. Please.
Yeah, good afternoon.
Good afternoon, sir.
Yeah, I am Professor Tamil Arasu
Okay, sir. Tamil Arasu, sir. All right, sir.
from Gambela University. From Gambela University, belongs to Accounting and Finance Department.
Okay, sir.
First of all, I would like to appreciate you and a great appreciation for the management of Gambela University. Really, it is a nice session to learn about the dimension. 0 dimension, 1 dimension, 2 dimension, and 3D also. And I would like to expect 4D as well as 5D from you. Okay.
Yes.
Okay. Even though
Yeah.
I am belongs to business and economics, you have mentioned here in 2nd dimension, some job opportunity will be available for economists.
Job opportunity for economics.
Yeah, economists and the business people,
Hmm.
there would be job opportunity from 2nd dimension. You have explained from your
Yes.
slide.
Yes, sir. Yes.
Let me have some example. What types of job opportunity we can get from 2nd dimension, please, madam?
So as far as the technocrats are concerned, sir, we can think of material fabrication using, incorporating these 2D materials into maybe for 3D printing applications, for example, we can use it. The futuristic, people started exploring other planets where we are looking forward for a viable solution because our planet is being exploited these days. Many of the researchers and ISRO and NASA, they are all focusing towards exoplanets, and they are trying for a for a survival, or more exposure is being done in that area. So 3D technology is a possible solution, incorporating graphene, 2D, this boronitride, molybdenum disulfide into the existing materials which are being used, and making filaments out of which, and using it for the printing process. So wherein we need not carry the material to the outer space to build up the homes or build up the things for living. So in that case, we do not know the climatic condition, how it is going to affect the survival of humans there. So in that case, to start with, we can employ these, incorporate these materials' potential property into the filament fabrication. So people who are working on with filaments can think of this incorporating of 2D materials into filaments, so that the potentiality of the material can be explored, and hence there are more room for these materials. This is one of the solution which I could offer to you, sir. And as well, I told you about the sustainability also. Wherever sustainability is a concern, we can take up the 2D materials, because it is a recyclable material. It is a renewable energy protection can be achieved with the help of these 2D materials, and substitution for silicon. Even silicon, replacing silicon, when people are thinking about with the 2D material. So these are the areas where industrialists can focus upon, and this is a new revenue generating area, and it is a research. Is it okay, sir? Are you convinced?
Thank you. Thank you very much, madam. We agree. Thank you very much, madam.
Please,
Yes,
any other
sir, thank
question?
you.
No.
Yes, good afternoon, everybody. I am Rajesh here. Can I go ahead with the question?
Please, sir, please.
Yes, I hope I am audible. So, thank you very much. It is a very eye-opening session, and I actually am from the industry part of it. So, we look at commercialization of technology, and so my question to Dr. Bindu is that what stage is this research right now in terms of 2D, and how can we, how soon do you see that this will be, this can be brought to commercialization? Because, the sustainability is an important fact for us today and not the future. So as I see the presentation shows about sustainability, just wanted to ask this question and how the academia and industry can work together to actually build this up. Yes, ma'am.
Yeah, actually, graphene being the first material which has been developed, I have already explored some of the very vital properties of graphene. So people have started, taking up this material into the industrial segment and started building flexible devices. Maybe in the near future, we are thinking of materials which are very flexible, easy to handle, lightweight and all that. So now the industry is has already started working with graphene-based 2D materials, and graphene and graphene-related materials are being brought up to the market as well. Whereas the potential materials, there are associated other potential materials also, which has got similar kind and better kind of properties, are not actually taken to the industry. Maybe the research is in progress, and with the collaboration, as you rightly said, with the collaboration of academia and industry, definitely this is going to be a phase changer, and it is going to give a future for our upcoming generations as well. So we look forward for a possible collaboration with you, sir, with our new kind of material that we are working in. As you said, you are an industrialist.
Thank you for answering.
Thank
Sure.
you, sir. Thank you, sir. Any more questions? Any more questions? Sir?
Okay, as far as there is no more questions, I give a very good appreciation to our speaker, Dr. B.Bindhu madam, for giving a very good inspiration speech regarding that sustainability research. And I'd like to thank the members from Gambala University for patiently waiting during their lunch hour itself, because I think this is the lunch hour for Gambala University. Patiently, they have waited for the lecture session to over. And thank you for everyone. And please complete the survey, and you can get the certificate contribution certificate. And I will request our madam to send the PPT slides for all the participants for a clear-cut explanation.
Definitely. Thank you, sir, for your patient listening during this lunch hour.
Thank you.
Thank you.
Jagat sir, shall we wind up?
Yes, sir. Yes, sir. Thank you so much, sir.
Okay, thank you, everyone.
Thank you, sir. Thank you, sir. Please send the presentation, sir. PPT.
Cheers.
Sure. Thank you, madam.
Thank you, sir. Thank you.